Hi, today we are going to learn about elementary principles of mechanics. So, the major objectives of today's class are we will be giving a small introduction to what is actually classical mechanics. Then, what is the concept of single particle? A single particle എന്ന് പറഞ്ഞാൽ ഫിസിക്സിൽ എന്താണെന്ന് നമ്മൾ ഡിസ്ക്രൈബ് ചെയ്യും. Then we're saying what is a frame of reference, and we'll conclude with seeing what is degrees of freedom. Now, classical mechanics എന്ന് പറഞ്ഞാൽ എന്താണ്? Classical mechanics is a branch of physics that describes the motion of macroscopic objects under the influence of forces. ഫിസിക്സിന്റെ ഒരു one of the fundamental branches ആണ് classical mechanics എന്ന് പറയുന്നത്. And what does classical mechanics deals with? It deals with macroscopic objects. Extended ആയിട്ടുള്ള വലിയ ഒബ്ജക്ട്സിനെ കുറിച്ച് പഠിക്കുന്ന ഫിസിക്സിന്റെ ഒരു ഫണ്ടമെന്റൽ ബ്രാഞ്ച് ആണ് classical mechanics എന്ന് പറയുന്നത്. In your lower classes, you had been familiar with kinematics as well as dynamics. Kinematics എന്ന് പറഞ്ഞാൽ എന്താണ്? Kinematics describes the motion without considering forces. When the object is at rest, we doesn't consider any forces. Then that branch of physics എന്ന് പറയുന്നത് it is kinematics. Now, what is dynamics? When an external force is acting on an object, then how does we learn the stuff? We learn with another branch of physics which is known as dynamics. Now, in Newtonian mechanics, പണ്ട് കാലത്ത് it was thought to be universally applicable. നമുക്ക് എല്ലായിടത്തും it can be applied എന്നായിരുന്നു ന്യൂട്ടൺ മെക്കാനിക്സിനെ കുറിച്ച് പണ്ട് കാലത്ത് ചിന്തിച്ചിരുന്നത്. But later on, during the 19th century, ആ ഒരു application എന്ന് പറയുന്നത് it was at a failure എന്നാണ് കൺസിഡർ ചെയ്തത്. Now, what are the limitations of Newtonian mechanics? ഒന്ന്, when an object is moving at the speed of light, suppose we consider this phone, this device. When this device is moving at the speed of light, what is the speed of light? The speed of light in the it is 3 into 10 power 8 meter per second. So when this device is moving with the speed of light, can we apply Newtonian mechanics? No, definitely we cannot apply Newtonian mechanics. So when an object is moving with speed closer to the speed of light, we cannot apply Newtonian mechanics. അങ്ങനത്തെ ഒരു branch of physics-നാണ് നമ്മൾ എന്ത് പറയുന്നത്? We call it as special relativity. When an object is moving with the speed of light, we take the help from special relativity. Now, quantum mechanical particles are subatomic particles. What are the subatomic particles that you know? The protons, the neutrons, and electrons. All these particles are very, very small. We cannot apply this Newtonian mechanics to subatomic particles. So, in that case, we apply only quantum mechanics. Quantum mechanics ennulla physics inde another fundamental branch aanu. We apply for objects with very small mass or small kinetic energy. So here we had learned two limitations. One is we cannot apply Newtonian mechanics for objects moving with velocity closer to the speed of light. The second thing that we have learned is quantum mechanical particles. You cannot apply Newtonian mechanics. So, according to modern science considers Newtonian mechanics as just an approximation. We can apply Newtonian mechanics only to large, macroscopic, slowly moving objects. വലിയ slowly moving objects മാത്രമാണ് നമുക്ക് Newtonian mechanics apply ചെയ്യാൻ പറ്റുള്ളൂ. Okay. Now, during the late 16th and early 17th century, you can see here the images of Sir Isaac Newton as well as Galileo Galilei. Sir Isaac Newton, അതുപോലെ തന്നെ Galileo Galilei laid the foundation for classical mechanics, laid the formulation of classical mechanics. Later, in the 19th century, it was reformulated. In classical mechanics, it was reformulated using some mathematical reformulation by Euler. You can see here the image of Euler, Lagrange, etc. So in this course of classical mechanics, you will learn classical mechanics with the reformulation or with the help of mathematical concept. Now, what is motion of a single particle? So before moving on to that, let's see what is called as particle. Particle എന്ന് പറഞ്ഞാൽ it represents an object or objectനെയാണ് which is of negligible small size describing its motion. ഇതിനാണ് നമ്മൾ particle എന്ന് പറയുന്നത്. Now, നമുക്കറിയാവുന്ന ന്യൂട്ടൺ ലോസ് ഒക്കെ നമുക്ക് എവിടെ അപ്ലൈ ചെയ്യാൻ പറ്റുക? We can apply Newton's laws only to particle. Can we apply Newton's laws to extended objects? Extended objects എന്ന് പറയുന്നത് മാക്രോസ്കോപ്പിക് ആയിട്ടുള്ള ഒബ്ജക്ട്സിന് നമുക്ക് ന്യൂട്ടോണിയൻ മെക്കാനിക്സ് അപ്ലൈ ചെയ്യാൻ പറ്റുമോ? പറ്റും. But in that scenario, suppose again this phone. You all know this phone is made up of many n number of particles. N number of particles വെച്ചിട്ടാണ് ഈ phone അല്ലെങ്കിൽ ഈ device ഉണ്ടാക്കിയത്. Now, how can we apply Newtonian mechanics? നമുക്കറിയാം this phone is having a center of gravity. What is center of gravity? It is a point where every mass is concentrated. So Newtonian mechanics prakaram namukku Newton's laws apply cheyan vendite we consider the center of gravity and then you apply this Newton's laws to that particle. അങ്ങനെയാണ് extended objects ന് നമ്മൾ Newtonian mechanics apply ചെയ്യുന്നത്. But is there any limitations for particle approximation in Newtonian mechanics? Definitely the answer is yes. Let's see again with an example. It works well for a planet's motion around the sun. You all know galaxy, Milky Way galaxy. ഈ മിൽക്കി വേ ഗാലക്സിയിലാണ് നമ്മുടെ സോളാർ സിസ്റ്റം എന്ന് പറയുന്നത്. This solar system centerലാണ് നമ്മുടെ sun എന്ന് പറയുന്നത്. So as a whole, you can consider the sun as a particle, or if you consider a planet, if you want to learn about the planet's motion, suppose you want to learn about Earth's motion around the sun, you can consider planet as a particle. അത്രയും വലിയ ഒരു ഗാലക്സിയിൽ you can take this planet as a particle, treating it as a point object. But suppose you want to learn about a planet Earth. Suppose you want to learn about the planet's rotation. Can we consider it as a particle? No, you cannot approximate it as a particle. You have to consider നമുക്ക് അവിടെ പാർട്ടിക്കിളിന്റെ സൈസ് കൺസിഡർ ചെയ്താൽ മാത്രമാണ് പ്ലാനറ്റിന്റെ റൊട്ടേഷൻ എന്നുള്ള കോൺസെപ്റ്റ് നമുക്ക് സ്റ്റഡി ചെയ്യാൻ പറ്റുള്ളൂ. So these are the two limitations of the particle approximation. Now, moving on to the next concept, what is frame of reference? Frame of reference എന്ന് പറഞ്ഞാൽ it's a system of reference points used to define and measure the position and motion of objects. ഒരു ഒബ്ജക്റ്റിന്റെ പൊസിഷൻ ആസ് വെൽ as മോഷൻ ഡിസ്ക്രൈബ് ചെയ്യാൻ വേണ്ടിയിട്ട് യൂസ് ചെയ്യുന്ന ഒരു റെഫറൻസ് സിസ്റ്റം ആണ് എന്ത് ഫ്രെയിം ഓഫ് റെഫറൻസ് എന്ന് പറയുന്നത്. Let's see with an example. Here you can see here this is a train which is moving with a velocity 60 meters per hour. Now suppose I'm sitting, my name is A and I'm sitting inside the train. You are B. Again, you're sitting inside the train. നമ്മുടെ ഒരു friend C is standing outside on the ground, outside the train. Okay. Now here you can consider two frames. രണ്ട് frames നമുക്ക് ഇവിടെ എടുക്കാൻ പറ്റും. What are those two frames? The first frame എന്ന് പറയുന്നത് it's inside the train. A. I am A and you are B. What is my velocity with respect to you? You appear stationary for me. Inside the train, even the train is moving, എനിക്ക് നിങ്ങൾ stationary ആയിട്ടാണ് തോന്നുക. What is my speed then? It is 0 meters per hour. Now, as I have said, my friend or our friend is standing on the ground outside the train. So, relative to our friend, what is our speed? നമ്മുടെ speed when an observer on the ground sees the train moving at 60 meters per hour. The speed എന്ന് പറയുന്നത് our speed എന്ന് പറയുന്നത് it is 60 meters per hour. So you can see here you have considered two frame of reference. രണ്ട് frame of reference ഉണ്ട്. So the same object can have different velocities. നമ്മൾ പറഞ്ഞു Aക്ക് B നെ കാണുമ്പോൾ what is the velocity of A? It is 0 meters per hour. A appears to be stationary for B. Now for C, what is the velocity of A? is 60 meter per hour. So the same object can have different velocities depending on the chosen frame of reference. നമ്മൾ എടുക്കുന്ന frame of reference അനുസരിച്ച് there will be having different velocities. So you cannot say there is an absolute frame of reference. Absolute frame of reference എന്നുള്ള ഒരു concept ഇല്ല. This frame of reference is valid and it can be used to describe motion. Frame of reference നമുക്ക് മോഷനെ കുറിച്ച് describe ചെയ്യാൻ വേണ്ടി യൂസ് ചെയ്യാവുന്നതാണ്. Now, let's introduce the concept of degree of freedom. What is degree of freedom? Degree of freedom എന്ന് പറയുന്നത് it is the number of independent ways a system can move or change configuration. So, let's again say an example. Here you can see an atom. Okay, the atom or it is a particle. It can move along its place in a Cartesian system of x, y, and z. And this particle or this atom is not restricted to any force. ഒരു external force ഒന്നും അവിടെ act ചെയ്യുന്നില്ല. അങ്ങനെയാണെങ്കിൽ this atom or this particle can move along x direction, along y direction, and along z direction. അവിടെ degrees of freedom എന്ന് പറയുന്നത് it is this particle. For this single particle, the degrees of freedom എന്ന് പറയുന്നത് it is 3. Suppose you have an n particle system. If a particle is having if a particle is n particle system, then the number of degrees of freedom എന്ന് പറയുന്നത് it will be 3n. Now that's all for today. Thank you and happy learning.